So today everyone, I am Krishna here, and this video is about creating a programming in assembly language for calculating volume of a storage box that comes in a cylinder shape. So first of all, I am a information technology student from Mersing Polytechnic, Malaysia, and in this video, this is actually one of our projects in polytechnics to make a video on programming codes. So in this video I'm going to present about how to make a code in assembly language using EC68K, about how to create a program to calculate the volume of a storage box. So we're going to look at the actual question here. So the actual question is, okay, so the actual question is this one. So it says we have to write a program to solve the problem. The problem is Cecilia Sundrian Berhard wants to build two storage boxes with specifications as shown in figure 1. This one. You as a programmer in this company are asked to write the program by using assembly language to calculate the volume of the storage box. Program should start at address 1000 hexadecimal. This dollar sign indicates hexadecimal, and the last result is stored in data register D5. So this is the storage box. As you can see, the height of the storage box is 50 meters and the base of the storage box is 30 meters. So now we already know some information about the storage box. We can right away make the programming. Right away make the program. So in order to make this program, we have to have EC68K software. After we have this, we can create the program. So for the first step, we have to have the addressing, the main address of the programming code. As they told in the question, we have to have 1000 hexadecimal. So I put 1000 hexadecimal has the address of the whole program. So after I put that, we can actually start to write the instructions. So the first instruction format is move.b. This one indicates we're gonna move a data in byte size 32. This 32 is a converted number. We actually converted 50, which is the height of the storage box, in hexadecimal. So we will get 32. So I moved 32. This is the first data to D1, and the comment says height of the box 50 converted to hexadecimal equals to 32. It is not necessary for us to convert first before we put in data registers. We can right away put the height here, which you can right away put like hashtag a dollar sign 50D1. So after you execute it, gonna come out as 32 as well, because this old software is only running in hexadecimal. So after I executed, as we can see, it's already stored in D1, which is data register 1 32. So it is registered. Next we're going to do the next instruction format. Okay, so this one is Again, I'm gonna move the data in byte size, but this time I'm gonna move f. F is a converted number of 50. So as we can see, the storage box space is 50, 30. So 30 we divided by 2, we will get 15, 50. So as per the formula for the volume goes, we have to times height times space times pi j power 2. So after I split the after I split 30, I get 15, and I converted that 15 to hexadecimal, I get f. So I put f in D3. I moved f in D3. Here we can see D3 is stored in f is stored in D3, which means it's a good sign. So this is basically how the programming goes as next. So and then I actually moved data in byte size f. This f is another 15 of the base. So we split the base into two, so we get two f's, and then this one I move to d2 and d3. And then mulu means multiplication in assembly language. This one is to multiply base with height. So we actually multiplying base with height first. So as we can see, height is in d1, base is in d2. So I multiply one by one, d1 d2. So 32 times by 15, and then again the answer that I get from that I multiplied with another 15 because base. So the final answer that after we multiply will be stored in D3. And then again I moved data in byte as well. 3 is a conversion. I converted 22 per 7, which is the value of pi. If we convert 22 per 7 in hexadecimal, we will get 3. So I stored that in D4. So after I D4, I multiply with the answer that we get before. So D3 stored the answer of the multiplication before this. D4 is the 3. So after we multiply these two, we will get one answer which we didn't know yet. And then I move data to byte as well. This one is 2. Why 2? Because they actually wanted two storage boxes, so we need to know two volume of storage boxes. I mean volume of two storage boxes. So we multiply with 2. So D4 D5, again we using the same instruction, which is mulu. And then lastly I move data because they actually asked after we get the final answer we have to store the final answer in D5. So in order to do that, I move data in long word D5 to D1. So okay, here I actually after the last multiplication, the data is already stored in D5 as we can see, so we don't have to move it to another data, so it actually fits in D5. So after we did that, the move dot long word is actually to display the answer because the client Cecilius didn't really want to know the volume of the boxes, so we have to display the volume. So for that I actually use move dot long word This one is to this set of instructions is for displaying. So it goes like this: we have to use move hashtag 14 d0, and then we using lia text d1 a1 to put the text in d1. Okay, right now the text in d1 is the volume of two cylinders, so we have to put the text in d1 in a1, which is address register 1, trap hashtag 15. By the way, all these instructions should be put in order to display a program, a answer. And then move hashtag 3 t0, trap hashtag 15, move dot long word hashtag dollar sign 7 d1. So after we did that, we actually put the text d1 and what the text we're going to put in text d1. So in my case, I put the volume of two cylinders, and the answer will be displayed after the point sign, and then and start. We have to put and start. That's the right formula. If we didn't put and start, then the program will not run. So this is basically the final process, the final data that's stored in registers. As we can see, how the data actually stored. So the final answer is 107AC. So when it come out, this is how it will be displayed. This is the volume of two cylinders is 67500. This is the volume of two cylinders. This is actually the memory address of the this is the memory address of assembly of the program code that we have done just now. So as we can see, everything is in app. This is actually here we can actually see that uh, what are the data that involved at the last of the program. So these are the data. These are the data that stored in these data registers, and this one is what are the data that stored in memory address. There's only one data there's only one memory address content data, which is which is hexadecimal 1004. Others all zero. So I hope you guys enjoy this video and uh, find this video to be helpful in order to write your own program. So have a great day. Thank you.